All right, moving right along. We had kinetic energy. We don't have static energy, so it's not a perfect match to when we were dealing with frictions, but we do have kinetic and potential. So potential energy is energy something can use to eventually start moving. It wants to move and hasn't started yet. So think about something being up on a hill or above the ground. It has potential because if you let it go, it'll start to move or start to slide as it's moving downward. Don't worry about this one. So if you remember our potential, or rather our gravitational force question from earlier, that one was a bit of a doozy. The gravitational potential, even though it shares a word, is much easier to deal with. So little g on this one makes this a little bit easier to deal with. That's not really the reason, but at least it's nice that this is not a super tough question. Basically, it's the weight of the object. So mass and gravity, something we've seen several times before, but then multiplied by however far it's allowed to fall. So the force and distance, again, we come back full circle on our work and energy formulas. They share definitions. When we start plugging in numbers, there's no 1/2 in this one. It's just the numbers from here. We have a mass of 1951. Gravity is a number that I really hope you know by now. And then the height in this question is 1.26. Kilograms and meters per second squared make newtons. The newtons times meters, that's the definition for joules. So yeah, we get the units we want. All we need to do now is just evaluate, and running that all through a calculator, multiplying it together, appears to be about 240.91.